Okay, in this lesson, we're going to do, this is a little hyperbola review, just put together right before our quiz, just again, another review here. So let's talk again about the two different types of hyperbolas. We have basically vertical ones, and we have horizontal ones. And again, for horizontal to work, what we're looking for is an x squared minus a y squared equals 1, whereas vertical is the exact opposite. Y squared minus x squared equals 1. Now again, another thing that a lot of students get backwards is when you compare to A, B, and C values, for both cases, we're going to have a squared plus b squared equals c squared. Okay, and notice the difference here. Hyperbolas, you have a minus sign in the equation, but a plus sign when finding your ABCs. So that's opposite, and just like the ellipse, where the ellipse is adding x squared and y squared, then it's a squared minus b squared. So you got to pick up on the difference there. So those are the two key differences here. And again, if I draw what a picture looks like for horizontal, we have elements like this, and vertical, we have our curves like this. Now that's the actual graph itself. Now what we used is, we dash in a box that gives us the guidelines, and through that box we have our diagonal asymptotes, and those help guide the curve. Now again, that's a very crude picture here. Let me just draw it in straight lines to kind of show you what's happening. So again, all the red is really just guidelines, and over here we have the same, and it's going to look something like that. Okay, so again, just a very schematic of what it looks like. All right, let's go ahead and take a look at examples. So I'm just going to write out an equation. We're going to have x minus 3 quantity squared plus, not plus, but let's make this hyperbola. So again, it's what we have to change, different than ellipses, squared minus y plus 2 squared equals 1. Now again, we have the values under here, and we're going to make this one 16, and we're going to make this one 9. Okay, and keep it nice and simple. Now what we have here is, first thing you want to do is identify the center of the graph, which I'm looking at positive 3, negative 2. So I'm going to go positive 3, negative 2, and there's the center of our graph. Now again, you want to determine, is this horizontal or vertical? Since x squared comes first, it's going to be horizontal, looking like that, and we want to identify the A, the B, and the C. So I'm going to write those off to the side. And the A is always what comes first, the positive value of this aspect. So this is going to be 4, which is simply the square root of 16. Then the B value is going to be 3, which is the square root of 9. Now to get the C value, once again, it's a squared plus b squared equals c squared. So again, all we have to do is take these two bottom numbers, add them together, and we're going to get 25. And that's what c squared is. So what's c? Simply going to be 5. So what I want to do is take this information and put it on the graph right away. So from here, we want to say, okay, let's since we're horizontal, we want to go left, right first. So 1, 2, 3, 4. So there's one vertex, and that's gonna, if you want to put a little label on it, a V. 1, 2, 3, 4 going this way. That's our other vertex. Then our B dimension goes up and down. 1, 2, 3. And then 1, 2, 3 down. And right here, now again, these are going to be dashed lines. So let me just go ahead and draw those in. And I could take my time here a little bit because so it doesn't look too bad. But again, it's important to recognize that these are dashed lines. They're actually guidelines. They're not a part of the actual graph itself. They just help us really get the asymptotes. And what are the asymptotes? Are the dashed diagonals that go diagonally through the box here. Okay, and from here, now what we can do is we can actually sketch in our curve. So it's going to hug alongside the asymptote, go through the vertex, it's the only part that touches the box, and go back up and there. And it goes on forever, so it'll show that direction. And the same thing here, it's going to come in here, go through, touch the vertex, curve out. It's a totally different curvature than circles or parabolas or ellipses, but we kind of see what happens there. Now, A couple of things I want to point out is, we should be able to recognize, okay, here's the vertices, here's the co-vertices here and here. Our foci is inside the curve, so again, it's our C value of 5, so we're going to go over 1, 2, 3, 4, 5. There's our foci here, there's your foci there. Okay, and the other big thing is what I want to do is write the equation of our asymptotes, the diagonal lines here. So I'm going to pick the center point, and I write in point slope 4. So it's simply going to be y plus 2. And where am I getting the center of information? I'm stealing it right from the original equation. Equals, and our slope. Now, how do we get to slope here? Well, here our slope is up 3 and then over 4. So there's our slope 3/4. Now, again, there's two lines, a positive line and a negative line. So I'm going to do positive 3/4 and negative. So I'm going to do positive, negative 3/4, and then times the x value of x minus 3. And that gives the equation of the two asymptotes. So again, y plus 2 equals plus or minus 3 divided by 4 times x minus 3. So again, this is just a little review on hyperbolas to help prepare you for your upcoming test.